This is Professor Pelton. This is part 3 of chapter 5, section 2. So make a general um, table of the possible outcomes based on what we know. So these are the coefficients up here, obviously. Right? And these are the powers or the exponents. Right? Okay, so if you have an even exponent, the outcomes have to be the same, right? So if you do a second power or fourth power of any number, whether it's positive or negative, it always ends up being positive, right? And if you multiply it by a positive number, okay, then that means the function is going to go in the positive direction twice. However, if you multiply by a negative number, then the function is going to go, whoops, I didn't write the function, I wrote x. Then the actual function is going to go down in both directions. Okay. Well, if you have an odd exponent, then if you plug in a positive, you get a positive. You plug in a negative, you get a negative. Pretty straightforward. So a positive coefficient doesn't really change anything. So the function in the negative direction goes negative, and the function in the positive direction goes positive. Okay. If you multiply by a negative, that's going to switch the outcome. So the function is going to go positive in the negative direction, and the function is going to go negative in the positive direction. So again, just do any example that you want, right? Do x to the even, we'll do a 6, and put a negative 3 out front, correct? So that is an even exponent with a negative coefficient, right? So that's an even exponent with a negative coefficient, correct? So what happens there? They both go down because you have to do exponents first, then multiply, right? You can test it yourself. You don't memorize, you just think about it using simple examples. Okay, so if we look at these, we can generally make assumptions now. Okay, which of the following must be the case? Well, these are going in the same direction, so that means it cannot be odd, because if I plug in a number into the odd exponent, positives and negatives will get different answers. Even will make the same answer. They're both going down, so the negative exponent makes the most sense, right? And this is 1, 2, 3 changes in direction, right? So this is probably x to the fourth power with some negative number out front, and there's some other terms afterwards. Who knows what they are, right? Because you plug in a number into there to the fourth power, it always gives you a positive answer, and the negative number makes it go down because a negative multiplier comes after the exponent. All right, the next one. This is not even because they're going in opposite directions. And if I look at this, in the positive direction, I'm going down. In the negative direction, I'm going up, which is opposite of what you would think. So this is clearly a negative coefficient, right? If I look here, 1, 2, 3, 4 changes in directions, it looks like in there. So that's x to the fifth power. Because again, I'm using the n minus 1 rule. If there's 4 changes in direction, add 1, I'm at 5. And I just put a negative number out front. So if I put a number to the fifth power, if a positive is a positive, a negative is a negative. However, the negative multiplier in the front will change that outcome, hence why it's a negative. Okay, so let's look at some algebraic ones. All right, so negative 2x to the fifth power. So a positive x will end up being a negative answer, and a negative x will end up being a positive answer. Just do it out for yourself, negative 2, and put a positive number to the fifth power, and then do negative 2 times a negative number to the fifth power, right? The exponent has to come first, the multiplier comes after, so that dictates the end behavior. So the graph essentially is going to go down in the positive direction and up in the negative direction, right? So if I look at the next one, these are both going to be positive, right? Because it's sixth power, which means no matter what I plug into there, it's a positive outcome. And the 3 doesn't change anything. All right, pause the video, try a student problem. All right, so the next one must be negative infinity for both of these, because that's always a positive outcome, but the negative after makes both answers negative. Okay, and the next one, in the positive direction, I'm going to go positive. In the negative direction, I'm going to go negative. Because no matter what I plug into x to the third power, positive stay positive, negative stays negative, and the 3 doesn't change anything. Okay, so based on these general assumptions of end behavior being only 4 possible outcomes, we can do general graphs pretty quickly. So we just need to know the leading exponent, leading coefficient, maximum number of changes in direction, and we can sketch the graph. Okay. Again, I emphasize sketch, not draw. We're not doing exact graphs. So the leading exponent is 3, which is an odd number. The leading coefficient is -4, which is negative, right? Because that is our leading term. Or is it? No, it is not. That is our leading term. Because leading term is not defined by what's in front. It's defined by the greatest power, which in this case is the fifth exponent. Okay, so the leading exponent is 5, which is still odd, and the leading coefficient is 6, which is positive, right? So that gives me 4 changes in direction when I do the n minus 1 rule, because 5 minus 1 is 4. All right, so the end behavior, why did I circle even? That's odd. Sorry, that's an odd. I was thinking the 6 for some reason. All right, so it's odd. Positive. So in the positive direction, I go positive. In the negative direction, I go negative. Okay. And there are 4 changes in between. 1, 2, 3, 4. 1, 2, 3, 4, right? 1, 2, 3, 4. Good enough. Okay. All right. Next one. This is a leading term. Okay. So the leading exponent is 4, which is even. The leading coefficient is 7, which is positive. So the number of changes in direction is 3 when I do 4 minus 1. Okay, since it's even, the outcomes are the same. The positive direction is positive and the negative direction is positive. And the 7 in front doesn't make any difference. So there are 3 changes in direction. There we go. 3 changes in direction. So that is a general sketch of what the graph should look like if you graphed it in your calculator. Okay. Next 2. All right, so the leading term here is this one here, which is an exponent of 3, which is odd, and -2 is a negative leading coefficient. So since it's odd, whatever you plug in comes out the same, but the negative is going to switch it. So the positive direction goes negative, and the negative direction goes positive. And since this is the third exponent, changes in direction are 2. There we go. All right, so the last one is not in polynomial form. If I multiply it all out, it would be so I'd get -5x to the sixth plus dot 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 a bunch of other terms. But I'm not going to multiply this all out. You know what I'm saying? I'm not going to do that because all we need is the leading term. That's it. The other terms afterwards don't matter. Okay. All right. So if I do this, I get a 6, which is an even exponent, and I get a -5, which is a negative coefficient. Since this is even, they go the same direction, and negative goes down. So they both go down as a result, right? And again, test it for yourself. Plug a number into there. What do you get? If you plug a positive number in there, positive, the 6th power is positive, times -5 is negative. Plug a negative number into there. A negative number to the 6 is positive, times -5 is still negative. So the number of changes in direction is 5 because of the n minus 1 rule for the 6, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 changes in direction. Okay, so we're doing the maximum number of changes in direction. It could be less than that. And there is a way to figure out what it actually is, but we're not doing that because we're just doing a general sketch. So just assume it's the maximum for now for the n minus 1 rule. All right, pause the video and try the next page. Okay, so the next one, if I multiplied it all out, it would be in polynomial form. So if I multiplied this all out, it would be -4x to the 5th plus a bunch of terms afterwards, which are irrelevant. All we care about is the leading term, right? Because you have 2 x's here, and then 3 more x's make 5 x's. All right, so it is 5 exponent, which is odd, and -4, which is a negative exponent. Okay, so odd means opposite directions, and negative means in opposite of what you think. So the positive direction goes negative, and the negative direction goes positive. Since it's the fifth exponent, n minus 1 dictates 4 changes in direction. There we go, 4 changes in direction. All right, next one. This is the actual leading term, right? Which is an even exponent and a negative coefficient. So even means the same direction, and the negative means opposite of what you think. So these both go down. And since this is a second power, we only have one change in direction. And there you go. Okay, next two. Okay, so the leading term is the 5x, right? Which is a 1 exponent, right? Because this is 5x the first power, correct? And a positive coefficient, okay? All right, so that means it's going in the direction you think. So odd is opposite direction, so positive goes positive, and negative goes negative, okay? And there are 0 changes in direction because 1 minus 1 is 0, which makes sense. This is a line, right? Okay. All right, next one, x to the 8th power. There's a 1 in front of that, right? So 8 is even and 1 is positive. So that means we're going in the up direction, right? Because anything to the 8th power is a positive outcome. 2 to the 8th power is positive and negative 2 to the 8th power is positive. So in between, we have 7 changes in direction. 1, 2, 3, 4, 5, 6, 7. That's pretty good. Okay. Again, sketches. All right. That is the end of part 3.